Okay, let's solve this interesting little math problem. So we have a train, and this train has gone 30 miles in 17 minutes. So we're trying to figure out how far the train will travel in 1.5 hours, 1.5 hours. And of course, we're assuming that, it's not changing its speed. And again, the train has already traveled 30 miles in 17 minutes. Okay. How far is it going to travel in an hour and a half? So we're going to get into this problem. I'm going to teach you how to solve this in two different ways, and it's going to reinforce two major concepts in algebra that you need to know. Okay, so I definitely would encourage you to pause the video and see if you can figure this out on your own. Anytime you think you can do any of these math problems, you should be like, let me just go ahead and do this, and then kind of compare what you did with what I am going to do. But you're certainly going to walk away from this video just reinforcing two major concepts in algebra. We're going to get to this in just 1 second. But first, let me quickly introduce myself. My name is John. I'm the founder of TabletClass Math. I'm also a middle and high school math teacher, and over several years, I've constructed what I like to believe is one of the best online math help programs there is. Of course, I'll let you be the judge of that. If you're interested, you can find the link to my math help program in the description of this video. But I offer like over 100 courses. Okay, of course, those would include Algebra 1, Geometry, Algebra 2. I'm going to be launching my pre-calculus course here very soon. Pre-algebra I have, but I also have many, many, many specialty courses, things like for the GED math section, or the SAT or ACT math prep, or GRE, or if you're taking a college placement exam or a teacher certification exam. I have a lot of specialty type of math courses, test preparation. So, and of course, I do a lot with independent students like homeschoolers. So wide range of uses for my courses. Then all my courses have complete comprehensive lessons, much more than what I do on YouTube. And I solve thousands of problems, really the most common problems you're going to face in middle school math, high school math, and even basic college level math. Now, if you are a math student, I must tell you my golden rule of teaching math, and this is what I've learned over decades of teaching the subject, and that is those students who take the best math notes almost always have the best math grades. And those students who don't take notes, they just don't think it's important. Uh, or they take sloppy notes, or maybe they take notes every other Friday, okay? Because they're like, listen, my best friend, they take better notes than me, so I just use their notes before the test because I really have to keep up on my Instagram account. I got a lot of stuff to do. I got to do my homework from my other class and my math class. Listen, you get the idea. And by the way, in the good old days when I was a student, I was making all these mistakes, but there was no cell phones around there. But I can only imagine the kind of trouble I would have gotten in if I had a smartphone back when I was in college or high school. It would have been a disaster, I'm sure. So you got to really stay focused. You got to work hard at taking notes. And that's why note taking is critical. So if that this applies to you, and it probably applies to the majority of students, just believe me, there's only those. Not there's not a lot of students that take excellent notes. Okay, there's a lot of people that take average notes, but to take great math notes, it really takes a lot of effort. So there's room for improvement for everybody out there, for the most part. So as you're improving, you still need something to study from. So I actually offer excellent math notes, detailed, comprehensive notes to include pre-algebra, algebra 1, geometry, algebra 2, and trigonometry. You can find a link to those notes in the description of this video as well. Okay, so let's get to our problem here. So this is kind of a classic algebra problem. It's definitely something that you should know how to handle, at the, I would say algebra 1, even a pre-algebra kind of level, or any kind of basic standardized test will have a problem something like this, okay? So what's going on here? Well, we have a motion problem, okay? And these are very common in mathematics. In other words, we're dealing with distance and time and speed, this type of thing. So, it's going to behoove you to know how to solve motion problems, and they're very common. In other words, they're very similar, okay? Once you know how to solve one or two different flavors of these type of problems, then you should be able to generally solve all these type of problems. So let's kind of look at the skills that you're going to want to know to approach this problem. Now, there's two ways you can approach this particular problem. All right, so the first is we can use proportions, all right, to solve this problem. And I'm going to show you how we use proportions to solve this particular problem. And then we're going to also show you how we can use a formula, okay, to solve this problem. So the formula, I'll get to this proportion thing here in a second, but the formula you need to know, and you want to commit this to your long-term memory, is the following. Rate times time equals distance, all right? So rate times time equals distance. This is our standard formula that relates distance, time, and rate. Rate is another word for speed or velocity. There's some technical differences in those words, but this is the basic formula that you want to remember. Now, the one thing about using this formula or any formula, you need to understand units of measure. Okay, this is very, very, very important. Units of measure, very, very important. So, for example, let me go ahead and erase this. Let's just think about this for a second. If my distance in my problem is in miles, okay, and my time is in hours, okay, all right, so I'm measuring time in hours and my distance is in miles, then my rate will be miles per hour, okay, miles per hour. My speed, okay, or velocity will be miles per hour. So you have to really be thinking about, hey, is my time, is it measured in minutes, seconds, hours? Is my distance measured in feet, inches, miles? So we need to oftentimes convert units so we get the units that we want so we can answer the question and the kind of units that we want to answer it in. So in terms of rate, and I didn't explicitly say, hey, give me the rate here in miles per hour, but you kind of can assume that. And of course, if this was an actual test question I was making, I would be very specific about that. But anyways, so when you're dealing with formulas, you need to really, really know the units of measures that you're dealing with. And if you are struggling in this topic, go ahead and check out some of my additional videos on converting units, and I have a lot of other videos on this in my pre-algebra and algebra playlist that can help you out. But of course, we're going to review this as we go through this problem as well. Now, let's jump over here to proportions, and I've done quite a few videos on proportions as well. Okay, you can find those again in my pre-algebra or algebra playlist. But a proportion, by definition, is one fraction that's equal to another fraction. Okay, so for example, I have the fraction 1/2. And that is equal to the fraction 5/10, right? Or 3/6. There's any number of fractions, right? But a proportion is two equal fractions. Now, when you have a proportion, one thing that holds true is the means are equal to the extremes. That's just a fancy way of saying what I like to describe as the cross product, okay? So in other words, if I multiply across, this relationship is true. So 1 times 10, all right, is equal to 2 times 5. All right, so 10 is equal to 10. Okay, so when you have a proportion, all right, the cross product is true, and we want to solve proportions. So for example, if this variable was x right here, I could solve this proportion by using the cross product, okay? So I would have, 2 times x is equal to 1 times 10. All right, so x is equal to 5. Divide both sides of the equation by 2. X is equal to 5. Of course, we know that is the case. That's 5/10, so I have 1/2 is equal to 5/10, and there's my two equal fractions. So just a quick review on proportions and the rate times time equals distance formula and the things that we need to consider. Now, if you feel like, oh, okay, I kind of remember this stuff, I think I could do this problem now, go ahead and attempt this problem by using either proportions or the rate times time equals distance formula. You should always try to do problems on your own before you. Here's the thing. Let me just state it this way. Watching someone do math is not the same as you learning math. This is one of the biggest mistakes students do. They'll sit and they'll watch a bunch of videos on someone solving math problems. That's not really going to help you that much. What you need to do is you can watch someone solve the problem, but unless you attempt the problem itself, and you can do the exact same solution as a person. Like, for example, I'm going to solve this problem. You can try the problem on your own and just try to practice what I'm teaching you. But that's what you need to do to really improve your skill, your math skill. Okay, just don't watch the video and be like, okay, I understand it, and move on to the next thing, right? You have to do the work yourself ultimately. All right, so there's the problem. If you think you could do it with either proportions or using the rate times time equals distance formula, go ahead and do so. But in the meantime, let's go ahead and get into the solutions here, and we'll do it both ways. Okay, so here is our problem. And we'll go ahead and use the formula first. Rate times time equals distance. So what do I have here? Well, first of all, let's just figure out what is the question. I'm asking how far. So how far the train went. I'm looking for what? Am I looking for rate, time, or distance? Well, I'm looking for distance, right? That's the question, okay? Now, what do I need to get the distance here? Well, I'm going to need the time and the rate, okay? All right, so do I have the time? Yes, I do have the time. It's 1.5 hours. That's good. But I don't have the rate. I don't have the speed of the train. Okay. So how can I get the speed of the train? Well, when you have a math problem, you always use the given information. Okay. So what's the given information? Well, I'm told something about this train. Okay. I'm told that it's going 30 miles in 17 minutes. So is this enough information for me to get the speed of the train? Well, let's consider rate times time equals distance, okay? I need the speed, all right, to get the distance here, right? But right now I'm thinking, well, how do I get the speed? Well, let's go back to this information. So the speed is the rate, okay? In order for me to get the rate, I need the time and I need distance. So do I have time? Yes, I have time, 17 minutes. And do I have distance? I do have distance, 30 miles. Excuse me. So I know that this train traveled 30 miles. Well, my voice is breaking up here. Excuse me. I'm plowing through it. I'm plowing through it. So I know the train has traveled 30 miles in 17 minutes. So that's enough information for me to get the rate. Okay, so how would I solve for the rate? Well, the rate is going to be equal to the distance divided by time. Okay, so I've done videos on how to solve for indicated variables in formulas. Okay, but I would essentially divide both sides of the equation by t. So the rate is going to be equal to the distance divided by time. Again, if you're confused about this, take a look at some of my other videos on solving for particular variables in formulas or indicated variables. You can find all this in my algebra playlist. Okay, so of course we have multiple things going on here, right? This is not just going to be a direct way to go. So to figure out how far this train went in an hour and a half, okay, I'm looking for distance. I have the time. I'm going to have to get the speed. How do I get the speed? Well, I'm going to have to figure out this other little problem here. Once I got the speed, and then I can come back and do this. Okay, so let's get to it here. Now, I got a little bit of a problem. Not a major problem, but I want to work in miles per hour. Okay, so I'm looking for the rate, the speed of the train, and I want that in miles per hour, right? But I have a problem, okay? I'm not told how far the train went in terms of hours. I'm told of how many minutes it took for this train to go 30 miles. So I want to convert those minutes to hours. I want to work in hours, okay, because I have miles because I want to figure out miles per hour, okay? So let's go ahead and convert 17 minutes to hours. Now, how do I do that? Okay, and this is why I like this problem because we're doing a lot of different problems. Okay, a lot of different skill sets that you need to know how to do, like converting one unit to another unit. So we have 17 minutes. I want to go from minutes to hours. So I want to multiply that 17 minutes by what we call a conversion factor. Okay, something that we know is true that relates both hours and minutes. And what is that? Well, we know that 1 hour is equal to 60 minutes, or 1 hour, okay, 1 hour per 60, 1 hour per 60 minutes. Okay, now another way we can express this is 60 minutes per 1 hour. So which conversion factor do we use? Do I use this one? And of course I am using this one, Okay, but why am I not using this one, 60 minutes per 1 hour? Well, this is a fraction, okay, 17 minutes over 1. You see here, this units of measure, minutes and minutes, these guys will cross cancel, all right? So I want a 1 minute in the numerator and another minute in the denominator so they cross cancel. And when they do cross cancel, I'm left with what I want, the unit of measure of which is hours. If, let's kind of reverse this here for a second. If I had this way, 60 minutes over 1 hour, guess what? I would have minutes times minutes. I would have minutes squared over an hour. Okay. So that would, that's not going to help me out. So you need to know how to work with units of measure and convert units of measure. Very, very important. So a lot of moving parts in this problem, but nothing that we can't handle. We're just going to take it one step at a time. All right. So we got 1 hour per 60 minutes. The minutes cross cancel. And now I have 17 times 1 over 60. So this is just a fraction. And of course, our answer is going to be an hour. So 17 over 60. I go into my trusty calculator. And 17 divided by 60 is 0.283 hours. And there is more threes here, but we'll just round it off right here, 0.283 hours. And that makes sense to me, right? It's not 1 hour or over 1 because 17 minutes is less than 1 hour. So less than 1 hour. So 0.283 hours. So now what we can really think about is that this train went 30 miles in 0.283 hours. Okay, I want to work in hours, not minutes. Okay, so now I need to figure out my rate still. Okay, I'm still not there yet. All I did was to convert units of measure. So again, I have rate times time equals distance. Now I want the rate. I want the speed of the train. Okay. Do I have the time? I do have the time, and it's in hours. Perfect. Do I have the distance? I do have the distance, and it's in miles. So when I divide, okay, remember rate times time equals distance. And when I divide both sides of the equation by t, I get rate is equal to distance over time. The distance is in miles, and the time is in hours. Okay, what does this mean to you? Miles divided by hours. Well, we state this way, miles per hour, okay? More commonly known as miles per hour, right? So that's the speed that we're going to get. So right here, to find out what the rate is, the speed is, I'm going to divide both sides of the equation here by 0.283 because we're using simple algebra. So divide both sides by 0.283 hours. 0.283. So now I could go into my trusty calculator and do, whoops, whoa, I was trying to use a highlighter, not that. Okay, so I was trying to going into my calculator, I'm going to take 30 divided by 0.283 hours, and I get approximately 106 miles per hour. So that train is going 106 miles per hour. Now the rest of the problem becomes very easy, okay? All right, so let's go back to the formula. Rate times time equals distance. Remember, the original question was, how far is this train going to go in 1.5 hours? Okay, well, it's traveling at 106 miles per hour. Okay, so this is good. Miles per hour times 1.5 hours, it's going to be 159 miles. Now, to be a little bit clearer on this units of measure, let's go here. 106 miles per hour, okay, times 1.5 hours, okay, this is hours, miles per hours. So you can see our units, hours, cross cancel, all right, and we're left with miles as our final unit of measure, so 159 miles. It's very, very important that you understand how to work with the units of measure. This is very applicable not only in mathematics, but like in science, especially like chemistry or any physical science where you're dealing with one unit to another unit, et cetera, et cetera. Okay, so this is one approach to solve this problem, 159 miles. Now, we're going to take another approach. We're going to use proportions now, and this is actually going to be a little bit easier. This is why you need to know there's not just one way to solve any problem. Generally, there's a couple of different approaches you can take. And now when you see this, you're going to be like, wow, this is maybe easier. Okay, so what do we know? Well, let's set up a proportion. So what does that mean? Well, we want to set up a fraction that's equal to another fraction. So we know that the train is going 30 miles per every 17 minutes. Okay. All right. So this is right here, miles and minutes. This is kind of basically we're thinking about its speed here, right? Okay. Now, what if it's going 30 miles in 17 minutes? As long as the speed's not changing, whatever we're looking for, how many miles, X miles that it will travel in 1.5 hours. Okay. This fraction, okay, this speed is the same thing as this speed. Remember, miles divided by time, right? Rate times time equals distance. And we're talking about rate equals distance over time. And that's what we have here, distance over time. This is speed, okay? So this is the speed of the train right here when it's going 30 miles for every 17 minutes. It's going to be the same speed as it goes how many miles it is going to go in 1.5 hours. So the speed's not changing, okay? So this is a very, very common way to set up a proportion, okay? And proportions are beautiful because they often are very direct and kind of a clean way to solve a lot of these problems, okay? So the train's going 30 miles per every 17 minutes. How many miles did it go in 1.5 hours? All right, so now here we have to do a little bit of a tweaking around here though, okay? So when you're setting up a proportion, okay, before you can solve it, the units of measure have to be exactly the same. So we have miles and minutes, okay? So here I want to know how far it went in miles, but I have hours here, okay? So let's just convert 1.5 hours to minutes, okay? So how many minutes is 1.5 hours, and that's an hour and a half, right? So 1 hour, of course, is 60 minutes, and 0.5 of an hour is 30 minutes. So 60 plus 30 is 90 minutes. I think all of you out there could figure that one out. Okay, so our proportion now really looks like this. We've got 30 miles. The train goes 30 miles for every 17 minutes. How many miles, X miles, did it go in 90 minutes, which is, of course, an hour and a half? This is the question. Okay, this is the original question. Now, all we need to do is that lovely cross product. We're going to multiply across, okay? And then when you know how to solve proportions, we kind of reviewed that at the beginning of this video, this will be good to go, okay? So we're going to have 17. We'll just forget the units of measure here because we know that our final answer for x is going to be in miles. So 17 times x is 17x. 30 times 90 is 30 times 90, and 30 times 90 is, of course, 2,700. So I just got to solve this basic equation here. 17x equals 2,700, and I'm just going to divide both sides of the equation by 17. And when I go into my trusty calculator, I go 2,700 divided by 17, I get the decimal 158.8. Okay, so this is, again, we're dealing with decimals, so there's going to be a little bit of rounding errors, but we can round that up to 159. Again, we know x was in miles, so this is 159 miles, okay? This is the same answer as the last time. So if you got this problem right, definitely give yourself a gigantic smiley face, an A++, and 1,000%, okay? You definitely earned it, right? Now, if you approached it with the formula, or you didn't know how to do it with the proportion, as long as you got it right, that's excellent. But you want to know how to handle a problem like this in both ways, okay? Proportions are excellent. That's why, so many problems can be solved with proportions. But again, when we have motion problems, you need to understand the rate times time equals distance formula. Okay, so hopefully, you're able to answer this question. If you weren't, the whole idea is to teach you how to do this, okay? So don't be down on yourself if you were totally lost. Hopefully, at the end of this video, you learned something, okay? That's the whole idea here with me teaching, because I wanted to help you improve in math, and my goal is always to try to teach math in a clear and understandable way. All right, so if you enjoy this video, if you like this video, okay, please consider smashing that like button. I would like that. And if you're new to my YouTube channel, please consider subscribing. Been on YouTube for a long time. It's a great platform for someone like myself who is obsessed with teaching math, really just trying to help the entire world improve in math, one little skill set at a time. And again, if you need help in math, you know where to go. If you like my teaching style, my best help is going to be found by following the links in the description of this video. Okay, so with that being said, I definitely wish you all the best in your mathematics adventures. Thank you for your time and have a great day.